everybody, I hope you guys are having a good day. So in this video, we're going to talk about how to find the ending amount in a savings annuity situation. So take a deep breath and let's make this math easy. All right, so let's say that we were going to deposit $500 each month into an account that earns 6% interest compounded monthly, and we're wondering how much money will we have in the account in 30 years. So first of all, it's a really good thing that this compounding period matches this deposit period, because this formula only works if the deposit frequency and the compounding frequency match each other. So that's good that it started off that way. And that tells us that K is going to equal 12, and our deposit is going to equal 500, and our interest rate is 6%, and our time equals 30 years. And the problem asked, how much will we have in the account in 30 years? Or in other words, how much will we have at the end? So to find the amount of money that I'll have in my account at the end of the 30 years, I'm going to plug all of the numbers that they gave me into the savings annuities formula, because I'm consistently saving money and I want to figure out how much I'll end up with at the end. So I'm going to say my ending amount, according to the formula, will be 500 times 1 plus my interest rate divided by 12, because I'm compounding the interest every month, raised to an exponent of 30 times 12, because I'll have that many months that I'm compounding it, minus 1, close the parentheses, and then this whole thing is over 0.06 divided by 12. So to find the ending amount, I basically just need to calculate this, but this is something that's rather difficult or complicated to calculate. So I'm going to show you how I do it on my calculator, so that you can kind of see the process I go through. So remember, with order of operations, you have to start at the innermost part of the parentheses. So I'm going to start by simplifying this stuff, and then after I get that, I'm going to raise it to an exponent, and then I'll subtract 1, then I'll multiply by 500, and then divide by this number. But I would prefer to not have to write out a whole bunch of decimals, and I'd like to just keep my numbers saved in my calculator. So I'm going to do some little mini calculations before I start my big calculation, so that I know how much this number is, and I know how much this number is. So I'm going to start by doing 30 times 12, and because 3 times 12 is 36, I just kind of know off the top of my head that this is going to equal 360. And then the next little mini calculation I'm going to calculate is this fraction right here. So I'm going to do 0.06 and divide by 12. And that tells me that this fraction here is equal to 0.005. And this is also helpful because I needed to calculate that fraction anyway to start my big calculation. So I'm just going to leave that in my calculator, because this 0.06 divided by 12 is going to equal this decimal. Then I'm going to add 1 to this. And so this decimal I have in my calculator is the stuff inside this innermost part of parentheses right here. Then I'm going to raise it to an exponent of 360, because I figured out earlier that 3 times 12 is 360. And that gives me this decimal here. Then I need to subtract 1 from this decimal, and that gives me this number here. So this number I have right now is all of this stuff. And then I'm going to take that result and multiply by 500. And then I'll take that number and divide by this decimal that I found earlier. So I'm going to divide by 0.005. And when I do that, I end up with the number 502,257.52 . So this amount is the amount of money that I will have in the account at the end of 30 years if I deposit $500 every month. So why don't you pause this video and try this one on your own? and then restart it to see what the answer is. All right, so on this one, you should have ended up with $54,348.80. And if you didn't get this number, then go back and try your calculation again. And if you need to, rewind this video to see how I did my calculation for the previous problem. So I hope this was helpful, and I hope you guys have a good day.